Hello, hello. I'm Professor Julio Rezende from Brazil. I am a coordinator of Space Analog Station Habitat Marte, and now I am starting the presentation about the main station. Today is October 2nd of 2021. We would be talking about how would be the operation of a main station on Mars. We are imagining a space station, a Mars station, presenting 7 facilities. The 7 facilities are the launch center, the main station, the health facility, the greenhouse, sanitation center, engineering facility, and power station. We can imagine in this station that the base station is supposed to be the first facility to be operational on Mars, okay, and giving support to other facilities, okay, in the station, okay. Uh, okay, let's go. In this case, we are in this presentation. I'll be talking about the main station. We are imagining that the participants of the analog space virtual missions, they are chiefs of the other facilities. In this case, I'll be talking about the 5 main topics: the internal design, the management, the protocols, also the spin-offs of this mission of this station. Okay. In this case, we receive a collaboration of architecture Brazilian student. Her name is Mariana Guerra. And Mariana, she proposed not only one facility in when we are talking about main station, but three models integrated using hexagonal shape. The name of this facility is supposed to be alpha, beta, and gamma. And these models, each model presenting different utilities. In this case, the alpha model is for prolonged use and it's a silent sector and resting. The second model, the beta, is for medium use and also social activities and leisure. And the third model is gamma, is for work and scientific experiments. In this case, in the alpha model, we are presenting the beds, the bedrooms, and the study room, also restrooms here. The beta model is presenting the kitchen, the dining room, the living room, also a gym. And the gamma model is presenting the mission control, training, and research room. In the alpha model, we present the bunks with 2 beds in each bunk. In this case, in this facility is presenting the capacity to receive 26 astronauts. It's important to say that the main station is the facility where all astronauts are sleeping. Okay, where the astronauts presented some personal materials. Okay, also there is 2 bathrooms in this area here. Also some elements of a vertical garden. Some reasons for plant support is related to evaluate the air quality. Also brings nature to space habitats. Also, this is important to psychological well-being, less stress, and more healthy and well-being. Also, it's important to bring some possibilities of vegetable productions, bring practicities and easiness to prepare the fresh meal. The concept of pick and eat, because in the main station we present the kitchen to prepare the food for to all astronauts. Also, this amazing and also pleasant place is interesting to help the meditation. Here we can see a concept of a dormitory. It's almost something like a roster. Uh, some of us sometimes would have the opportunity to be in a hostel and present bunks, okay, accommodate the two astronauts in each bunk. In this case, all the topic is a reading and study room. We can see here two proposals in terms of the content consumption. In this case, in the first photo, we have the astronaut reading a book, and the second photo showing the astronaut consuming the digital content. In this case, I imagine the approach more related to use of a lot of terabytes of digital content. In beta model, it's a model. It's also each model is presented three floors. Okay, each model is presented three floors. In the second model, the beta model is presented kitchen and dining room. Also, is presenting the living room and gym. This is a photo from a virtual meeting, a virtual environment in a Kitely. It's a virtual platform. This virtual platform was developed by Michael Lowry. It's presenting like something like a swimming pool or a place to entertainment, some music instruments. Also in this second model is presenting the kitchen with some vertical garden with some possible spices to take to prepare the meal, like sometimes the basil and also the lettuce, some ease plants to take to prepare the meal. Also is presenting a robotic a robot that would be useful to prepare the meal. This real example of robot developed by Mole Robotics. In this case, this robot presents like as a technology of machine learning, image learning, possible to read the labels of the food, also receiving, understanding the guideline of a person about how to prepare the meal. And this kind of robot would be useful to be used on Mars. In the dining room, we present tables for 10 astronauts. In this case, we would have shifts to like 3 shifts to to happen the meals. Also, the gym is a very important facility because we are imagining that space is very disturbing the possibility of loss of muscles and bones and also other health capabilities. In this case, very important the practice of exercise aboard of space station. Now we'll be talking about the third model, the gamma model. The third model is for the gamma model is for training and research and mission control. In this case, you can see here the how would be in the future the use of computers like multitasking resources. In this case, the computers would be useful for many tasks. And here you can see also the evolution of the panel of applied to control the vehicles. Also in the Apollo vehicle, the shuttle spacecraft, and more recently the Dragon. You can see the use of the introduction of small screens, and now more recently that applied to Dragon capsule from SpaceX, computer screens. Use it touching to the astronauts have access to the programs, the applications. In this case, we imagine in the main station is very important. A system like a dashboard to control the entire station. This dashboard is connected to greenhouse, to power station, to health center, to sanitation, also the main station. You can see here in the next slide a great expansion related to topics controlled from the main station, like in the greenhouse, the mission control, the commander need to know about the air quality in the greenhouse, also the water supply, also the inner temperature, about the demands of energy to supply the operation of the lightning. Uh, and there's a lot of topics important to follow up. Related to health, you need to look the temperature, also mental conditions, the heart rate, the calorie consumption, also periodical exams related to blood, urine, feces. It's very important we have the data about the health of astronauts and trying to predict possible health problems of astronauts. And from the main station, we'll be controlling the levels of water, food, and temperature. Also, the main station needs to contact the engineering center to follow up the conditions of external conditions, looking the weather, the temperature, the lightning, the wind, the possibility of dust storms, because on Mars is one of the great challenges are the dust storms, because some dust storms will be present at 20 kilometers of altitude, sometimes covering almost complete the planet. And this can be very dangerous for extravehicular activities. And the mission control need to know about these possible threats. Also, these dust storms will be covering the solar panels, also contributing to the loss of efficiency of the solar panels. Okay, in this case, it's very important to the main station presents all entire information to plan with the engineering center the extravehicular activities. Also related to power station, we need to know how is the generation of energy in each specific source, like the kilopower is nuclear power plant, also solar panels, also biodigester from the sanitation center, and other possible sources. Also, how is the consumption of energy in different sectors of the station, and how is the demand for the extravehicular activities? We need to know how the quantity of energy required to the operation of electric vehicles, okay, and other points. Just finish here. It's very important from the sanitation center to know about how many oxygen was produced, the quantity of water, because the sanitation center is like the heart of the station, because it's the place that where is produced the oxygen for the entire station. Also, is produce and recycle the water. And if the all systems of sanitation center fails, the station collapse because we not have more supply of oxygen and water, and this would be very disturbing. Because of this, is very important. Look, the main station keeps permanent communication with the sanitation center to know how all the systems are under operation. Okay. Also, something very interesting is during the extravehicular activities, the astronauts will be bringing back to the station the ice, the ice. This ice will necessarily need to be treated to represent clean water to be consumed by the astronauts. Okay. Okay, research room. Also, now I'll be talking about the third topic of this presentation related to applied technologies. In this case, you have like in the kitchen oven, fridge. Also, the entertainment area is interesting. Presents the virtual reality headsets. Also, spa hydro message, disco lighting, in control center communication technologies and antennas. Uh, Also related to possible resources to generate in situ and transported from Earth. We can see that almost everything will be transported from Earth. Maybe some utensils would be 3D printed on the main station. Also, part of food would be produced in the greenhouse. About the fourth dimension of this presentation is related to management. We can see in the main facility, maybe four positions, in this case, the commander, the executive chief, the chef, and general assistant. And now we'll be talking about each specific position. In this case of the commander, the required profile is a multidisciplinary background, as maybe someone from management or industrial engineering, someone with high capacity of leadership, intercultural competence, and also high personal resilience. And some duties are control of extravehicular activities and rovers, integrated with engineering center, also propose routines and guidelines to operational protocols, provide guidance to avoid risks, conduct educational activities, preparation for extravehicular activities, coordinated daily communication routines with space agencies like NASA, ESA, and ISRO, and other space agencies. Also keeps the communication with the specific facilities, the crew, and sometimes a communication with specific astronauts aboard of the station. The second position is the executive chief, is supplying support to the commander. A possible profile is someone from engineering or information technology or psychology. Some duties are the monitor all operations, keep all facility running, monitor routine maintenance, organize specific operations, coordinate trainings, and simulate self-sustainability when each one is observing self-organization, self-maintenance, and also keeping everything operational. The third position is the chef. Chef would be a cooker or a cuisine chef, a nutritionist or gastronomer. Some duties of the chef is the define menu, the meals, the food logistics, perform food preparation, assess teams' nutritional requirements, plan the availability of food, and define the feeding shifts. In this case, we have a photo from the movie The Matrix. The photo is presented the character Neo aboard of the Nebuchadnezzar ship. In the Nebuchadnezzar ship, he is eating all days oat milk. Okay, and in this photo he's complaining. He's very upset because all days is the same meal. In this case, one of the challenges to the chef of cuisine is prepare a very interesting menu in terms of the available food, available meals, trying to do different kinds of meal for astronauts. In this case, we have more two photos. The first photo is some pre-prepared meals transported from Earth. In this case, It's possible to see this small photo, I like something like a tube when the astronauts they did an infusion of hot water in this food, and the food recovers the properties as identified on Earth. The second photo is some meal collected in the Space Analog Station at Marte. In this case, we have photo from lettuce and pepper, and also the basil. And also to Mars, to be operating on Mars, is interesting to combine the food transported from Earth and the food produced on Mars. And the fourth positions is as an assistant. This astronaut is supposed to be an engineer, a psychologist, or an artist. And some duties are emphasize the team's well-being, also food management, support the chef, also coordinate the organization of the dormitory, coordinate the gym, and manage the laboratory tools, also apply some psychological service. And also related to training, some topics are related to new skills based on situations identified on Mars, also systems operation, new technologies, positions and tests of each astronaut, and simulation. Here we have some links of YouTube related to some useful topics like the operation of teams, also management of mental health, about some topics of music, some occupational safety and health, in other topics. We imagine in terms of resources necessary for astronauts, 1 kilo of food, of solid food, also maybe more water to prepare the food, and also some water to bath of astronauts. Some guidelines to be applied to other facilities, daily routines and scheduled activities, health occupation, health environment and safety guidelines, guidelines about how to maintain plants in specific space habitats, provide harmony and collaboration, make astronauts comfortable about to be in space, stimulate cooperation, innovation, creativity, emphasize the team's well-being, stimulate self-sustainability. And now we'll be talking about some protocols. We consider important protocols to harmony of astronauts, to deal with stress, to organize the room, to plant maintenance, to food production, okay, and also the maintenance of the infrastructure. Some protocols related to safety and health are related to hygiene, to wearables data collection, to health data collections, to deal with psychological balance, also protocols and simulations to deal with accidents. Some protocols for occupation are parties, celebration days, also according to each specific country. Also spa day, board games, yoga, and workouts, also related to mindfulness, and also content related to terabytes of music, movies, and books. Also, we have like a concept of a possible vertical garden, also related to protocols for food microproduction. Need to see the protocols for cultivations, for maintenance and detections of adjustments, to collect the plants, also the rotation, also best time for irrigation, male female flower pollination, and also plant cycle. Related to 3D printing, we can see the use of different techniques to printing utensils. Like maybe you can use clay to print pottery. Here you can see different 3D printers using clay and using powder, metal powder. In this case, also it's interesting to think about how to recycle this material. In this case, we need the projects to print the utensils, use the CAD programs. Also, you need to look the product degradation recycling protocols, also discarded the items to ground down to particles, also grinding the plastic, okay, to smaller particles in a blender. Also melting study to a plastic filament, and also restarting again the additive manufacturing process. Okay, in the last part of this presentation is related to spin-offs. You can see a lot of potentialities related to use of technologies for water savings, also the energy savings, and also recycling. As technologies aboard of the station would be applied to the also to Earth, okay? Also, some guidelines to be applied to daily lives on Earth are related to health, environmental safety guidelines, also mental well-being, daily routines and guidelines, also recycling mindset. All of these would be applied to Earth. And we can see the last part of my presentation is related to the impacts to sustainable development goals. We can see the impact to goal 3 related to health. The training of astronauts aboard of main station is related to goal 4. The also balance between women and men is related to goal 5. Also water saving is related to goal 6. The energy efficiency is related to goal 7. Waste recycling is associated with goal 12 and 15. Management is related to goal 16, and partnerships are related to goal 17. Okay, in this case, these are my contacts, and thanks so much for the attention today. Okay, thanks so much.